So we need to find the power series representation for G centered at 0 by differentiating or integrating the power series for F. We also need to give the interval of convergence for the resulting series. Let's start by working with f of x. We have to find the power series of g of x by differentiating or integrating f of x. First, we can write down that 1, the formulas which we will use this, is that 1 over 1 minus x equals the sum from n equals 0 to infinity of x to the power of n. We also will use the fact, let me write these facts here. So another formula which we will use is that the derivative of x to the power of n with respect to x equals n times x to the power of n minus 1. The other fact that we will use is that if sum from n equals 1 to infinity of an times x minus c to the power of n is a power series with radius of convergence r, then the interval of convergence is c minus r is less than x, and x is less than c plus r, where r is the radius of convergence. And another fact which we will use is that series of the sum of an times x to the power of n is convergent. If this sum is convergent, then limit of the absolute value of an plus 1 over an, where n approaches infinity, is greater than 1. Well, now let's work with our function f of x. So f of x equals 1 over 1 plus x, which equals 1 over 1 minus negative x. So we can use this sum right here, but we will substitute negative x for x. So it equals the sum from n equals 0 to infinity of negative x to the power of n. So it equals the sum from n equals 0 to infinity of negative 1 to the power of n times x to the power of n. So now we will differentiate both sides, and we will get that the derivative of 1 over 1 plus x with respect to x equals the derivative of this expression that we got right here with respect to x. So on the left side we get negative 1 over 1 plus x squared, and on the right side we get the sum from n equals 0 to infinity of negative 1 to the power of n multiplied by n times x to the power of n minus 1. Well, then we can rewrite it as negative 1 over 1 plus x squared equals 0 plus the sum from n equals 1 to infinity of negative 1 to the power of n times x to the power of n minus 1. So then we get that negative 1 over 1 plus x squared equals this expression. So this is the function which we were looking for. This is what we were looking for. And now we need to find the interval of convergence here. So an equals negative 1 to the power of n times nx to the power of n minus 1. And an plus 1 equals negative 1 to the power of n plus 1 times n plus 1 times x to the power of n. Then L equals the limit of the absolute value of an plus 1 over an, where n approaches infinity, and this equals limit of the absolute value of negative 1 to the power of n plus 1 times n plus 1 times x to the power of n over negative 1 to the power of n times x to the power of n minus 1, and n approaches infinity. Then this equals the limit of the absolute value of negative 1 times x times n plus 1 over n, where n approaches infinity. Then we get that this equals this equals the absolute value of x, and we need it to be less than 1 for our series to be convergent. So we get that x lies between 1 and negative 1. So